Hi everyone, this is my Physics Lab 2 report. An introduction would be the purpose and the objective of this lab was to observe the motion of an object that starts from rest and falls slowly, basically an object that's affected by air resistance. And then you use GlowScript and your data from Tracker, and it can be observed the difference between only the effect of gravity and then the difference between the effect of gravity with also the effect of drag, and this object is moving vertically. So the results, basically my computational model that only showed the force of gravity differed from my data in Tracker when graphed. The computational model that included the force of gravity and the force of drag was more similar to the plotted line of my data from Tracker. However, there was some deviance between the two, but I'll go more in depth about that in a little bit. So some important equations. We have Newton's second law, which is mass times acceleration, F net. Then we have the force of gravity. In this case, it is going to be in the negative direction, which is why I have my negative j hat, and g is equal to gravity. We have the velocity update formula. So v final equals v initial plus f net over m, change in t. Position update formula, r final equals r initial plus v average, change in t. Then we're going to have the drag formula. In this case, it would be negative bv squared v hat. But when I put it into GlowScript, we're not going to worry about this being negative because in this case, gravity and drag cancel each other out. All right, Tracker video. So I chose to drop a loofah because it was relatively light. So it started from rest, as you can see on my axes. So Tracker produced a position versus time graph, and we are focusing on the y direction because it is dropping vertically, so we're not going to worry about x. So the end of my graph up there is a bit wonky because when it did drop, it bounced a bit, and so I'm not counting that because that doesn't really matter. But it starts from rest, and I only use data up to 0.7 seconds when graphing on Excel. All right, GlowScript model 1. In this model, the net force only includes gravity. It's very important. So I made it my time interval less than 0.7 seconds. My f of net is just the gravity vector because, like I said, it only includes gravity. I had to put in a few equations that we talked about earlier that are important, the velocity update equation, and then the position update equation. And as you can see, the position versus time graph was a pretty solid arc, pretty constant with that. All right, GlowScript model 2. So this net force includes gravity and drag, and so I had to guess and check for the constant b, which my guess ended up not really being great. It's 0.98, but I'll get into that in a little bit. Everything else stays the same except for the net force. I had to include the vector of the ball.vel times y times ball.vel times y, so that the GlowScript could understand that I was not just including gravity, but I was also including drag. So that is why I added that in there. All right, here is my position versus time graph. As you can see, it's not a perfect arc anymore. It is, it deviates a little from the last graph we saw. And then as you can see, my velocity versus time graph is no longer just a constant slope anymore. It is curved inwards. All right, so when plotting all three of these lines on Excel, so the blue line is my computational model 1 that only included gravity. My gray one is the computational model 2, which included gravity and the force of drag. And the orange is my Tracker data. Now, the drag graph and the Tracker graph have the same shape. As you can see, especially from 0.4 seconds to 0.7 seconds, you can see that they're roughly the same, they're the same shape. They're just not very close to each other. And this could be due to multiple reasons. There's obviously a lot of error that can happen. My guess that I probably calibrated it wrong. I can't always get the point mass correct. Also, when I was doing B, typically when drag, B should be less than 1, but I could tell that my B needed to be probably greater than 1, and that's a source of error on my part. The force of the acting on my loofah is probably greater than I thought, and there's some error there, which is why they aren't close together. But some good news is you can definitely see that they are the same shape. Like the one that only includes gravity compared to my Tracker data, they're not very similar at all in the direction that they're going, but the gray one and the orange one, they do have similar directions. They almost look a little bit linear at the bottom, unlike the blue one. And like I said, I only use data from, or not data, I am analyzing 0.4 to 0.7 because that's where it looks most accurate. All right, so what does it mean? Which model predicts terminal velocity, and what does this mean for net force? So the computed model would drag force depicts this. So the terminal velocity is basically when the force of drag pointing up has balanced with the force of gravity pointing down. The only model that would depict this is the one that includes drag and gravity. So that would be the second model. So the net force would be 0, and in the velocity update formula, this would mean that the v final equals v initial because the net force is 0, so there would be no change in velocity. And no drag means that the model will continuously accelerate downwards. That would be like the first graph with the slope. Okay, what if the object was initially thrown downward, would terminal velocity change? So if we look at velocity of a function of time throwing, it wouldn't change the fact that drag and gravity cancel out. Drag is about the magnitude of drag force equaling the force of gravity. Initial velocity isn't relevant, so even if you threw it downwards, it would still be the same. So thank you.